Welcome back, pre-calc. So, Chapter 7, Section 3, Hyperbolas. This will be new to you, but there is a lot of similarities between this and ellipses. So, a hyperbola is two parabolas back to back is a good way to describe it. Definitely not the definition, but it looks like a parabola opening left, a parabola opening right here when they have a horizontal transverse axis. So transverse axis is the one that would go right through the vertices and the foci. There's a focus on the left and a focus on the right. The center is going to have coordinates hk, just like circles, ellipses, etc. The vertices are going to be a units left and right of the center. The foci are going to be c units left and right of the center. And there's a conjugate axis, so conjugate axis, which goes perpendicular to the transverse axis, and it is b units above and b units below the center to get to these co-vertices, which allow us to create this rectangle, which gives us these diagonals that cross through the rectangle, which are our asymptotes. So the hyperbola over here on the right gets closer and closer and closer to these two asymptotes, and the one on the left gets closer and closer to these two asymptotes. This equation right here, a squared plus b squared equals c squared, is going to allow us to figure out either a, b, or c, whichever one is missing. And it comes from this triangle that's created right in here. So a and b, and then the distance from the co-vertice to the vertice is also going to have c for its length, and c is that distance from the center to the focus as well. So you get this right triangle that's created, and that's where this a squared plus b squared equals c squared comes from. So a little bit different order than ellipses, so that can get confusing, but it goes back to very similar, or it is the Pythagorean theorem that we're very familiar with. The slopes of these asymptotes right here are going to have a slope of b over a. So the rise is b and the run is a. So that distance from the center to the vertice is on the bottom. That's our run, and our rise along the conjugate axis is b. The transverse axis, if it is vertical, so your transverse axis going from vertice to vertice. So if your hyperbola goes up and down, a lot of similarities. You can look that over on your own. The main difference is your slopes, your asymptotes. Now the slope has a rise of A and a run of B. So flip-flop what was going on over here. So you can pause that, go back and look at it. All right, graphing each parabola. So, or hyperbola. They have a subtraction sign, not a plus sign. That's why I know I have a hyperbola and not an ellipse. A is always the value that's underneath the positive term. B is underneath the term that's got the subtraction in front of it. The equation is always equal to 1, just like an ellipse. So this is A, square root of 49 is 7. And B is going to be the square root of 81, or 9. The center is going to be at 0, 0. There's nothing being added or subtracted to x or y. All right, so I'm going to graph this hyperbola relatively quickly. So I am going to have a center at 0, 0. And then I am going to go, just like the x-axis, this number is underneath x, 7 to the left and 7 to the right. So here's 7 right, 3, 4, 5, 6, 7 to the left of the center. And then I'm going to go up and down 9. So I wish I would have labeled this, but I think that's 10 units up, 10 units down. So here's 9 down from the center, 9 up, 9 down. That helps me create this rectangle That's going to give me a guide to help me graph my hyperbola. So now I'm going to throw in the asymptotes, which are these diagonal lines that go right through the vertices of this rectangle that I created. And they help give me a guide for my hyperbola when I'm graphing it. So all that dotted information is just a guide, not the actual hyperbolas. These hyperbolas open left and right, like the x-axis, that's the positive term. So this hyperbola has a vertice over here, and it opens to the left, like so. And this hyperbola over here has a vertice at 7, 0, and looks something like that. So hyperbola opening to the right, hyperbola opening to the left. A little sloppy, but all we need to do is sketch it. Graph this hyperbola. So it's going to have a center at -4 and +2. So I'm going to go to -4, +2. Here's my center. Okay, this one's also opening left and right because x is positive. So I know it opens like the x-axis. I need to go 2 units to the left of the center, and then 2 units to the right of the center. That's the square root of 4. I'm going to go underneath y is 9, so square root of 9 is 3. I'm going to go 3 up and 3 down, and that's going to make my rectangle. It's going to go right through that point. Oops, that point. All right, so now I can get my asymptotes, which are the diagonals of the rectangle. And those are just going to give me my guides. So my hyperbola is going to open from this point left, and from that point right there, right. I know it opens left and right because x has a positive value in front of it. Y's got the negative in front of it. All right, so I went back on to A and I figured out C, that distance to the foci. So using our equation, a squared plus b squared equals c squared, you get the square root of 130, which is like 11.4. So if I go 11.4 units to the right, oops, that's not my right pen. So 11.4 units to the right, that's one focus. So this hyperbola is opening around that focus. And then 11.4 over here to the left, this hyperbola is opening around that focus. All right, the equation or the coordinates for the vertices. This vertex is at -7, 0. It's 7 units to the left of the center. And I have another vertex over here at 7, 0. My focus, I'm going to write it as plus or minus the square root of 130, comma 0. It takes care of both of these. The slope of the asymptotes, so like this one right here in particular, I went up 9 and over 7. So my slope is 9 over 7. And then this one has a negative slope, down 9 over 7. So plus or minus 9/7. All right, I've done the groundwork here for this example 2. But here's our situation. It's not in standard form for an equation. So we need to complete the square to get it in that form. The y term, the y squared term's got the positive value. So I know this one's going to open up and down, like the y-axis. X squared's got the negative in front of it. So I group the y terms together, complete the square, group the x terms together, and complete the square. Now, you need to factor out -1 away from these x terms because to complete the square, you have to have a +1 in front of your squared term. So I factor -1 away from both x squared and x, and then I complete the square after that. I added 9 here, so I have to do 9 times 4, add 36 to this side. I added 4 here when I completed the square, so 4 times -1, -4 over here. These add up to 64. Divide everything by 64, and you get this equation. So I know this one's going to open up. Y is the positive term. The center is going to have an x coordinate of 2 and a y coordinate of -3. So I'm going to go to +2 and -3, and now I realize I have my graph the opposite way. I had it backwards in my mind, but it is +2, -3. I'm going to go up 4 and down 4 from here. So up 4, down 4, about here. I am going to go left and right 8. So from the center, I'm going to go 8 units to the right. So what was I supposed to be at? I'm supposed to be at 2. So about here. And then 8 units would put me over here about 6. All right, so I went 8 left and right. I'm going to make my rectangle and then my asymptotes, and then sketch in my graph for this hyperbola. So asymptotes are going to go, oh, that's bad, about here. The diagonals, that one's obviously not great, but my hyperbola is going to open up and down. So here's one vertex, and I have a hyperbola opening up right here. I could do better than that, but I'm running short on time. And here's another hyperbola opening down. So this hyperbola opens up and down because y is positive. All right, example 3, we're going to write equations of hyperbolas with the given characteristics. So this one has a focus, one focus at 5 negative, or 1 negative 5, the other one's at 1 1. So to figure out the center, it's halfway between these. So I'm adding the y coordinates, dividing by 2. I know the y coordinate here is going to be -2. It's going to have an x coordinate that's the same as those. So my center's at 1 -2. I also know this is going to open up and down if that's where my foci are, up and down. Transverse axis, so the long axis in between, or well, the axis in between the foci and our vertices is going to be half of that, so 2 units long. So that tells me A is 2. I can figure out that this is C, the distance from the center to the foci is 3 units. So C is going to be 9. Using this equation, I get B squared. So this hyperbola is opening up and down. I'm going to say y minus the y coordinate of the center. So y minus -2 is going to give me a +2. And I am going to divide that by a. A always goes underneath the positive term. So a squared, 2 squared. Hyperbolas are always minus, and then it's going to be x minus the x coordinate, which is 1 squared. And that's going to go over b squared, which is 5, and they're always equal to 1. All right, this one. So the vertices are at -310 and -3,2. So my hyperbola are opening up and down if those are my vertices. The center is going to be halfway in between 10 and -2. So add those together, divide by 2, you get 4 for a y coordinate, and the x coordinate is going to be -3. So the conjugate axis in this case, the one that's going left and right, is 6 units. So half of 6 is 3. That is what B is going to be. So again, this one's opening up and down. Y is going to be first. Y minus 4 squared over A. A is 6. The distance from the center to the vertex is going to be 6 units from 4 to 10. 6 units. So 6 squared. And then I'm going to subtract x minus the x coordinate of the center. So that's going to be +3. And that goes over B squared, which is 3 squared, so 9. That equals 1. All right, last example, less than a minute to get through this. So this hyperbola is opening up and down, no, left and right, because x is first. Center's at 0, 0. I'm not subtracting anything from x or y. I am going to go 3 units to the left and 3 units to the right. Then I'm going to go square root of 21, which is like 4.5-ish up and down. So 4 below, 4 above the center. And then my asymptotes are going to be about here and about there. My hyperbolas open right and left. And I'm going to have you come back and see what it looks like. All right, so here's our hyperbola. And here is your assignment.